Welcome back to trigonometry. This next section is going to be kind of a mix of things. We're going to first talk about reference angles for a bit, which I've talked about these before, but we're going to review them again because you're going to keep seeing these, and then we're going to eventually take reference angles and those special angles that we talked about in a previous podcast and put them together when we start talking about the unit circle. But for now, we're just going to talk about reference angles. Then we're going to explore some more how to use a calculator for certain functions, and then we're going to do a couple of word problem type, application type problems, and that'll wrap up, and that'll be this recording here for today. Okay, so reference angles. What's the deal? We've talked about these before. If you're trying to find your trig ratios, your sine, cosine, tangent, etc., of different angles, then you can think about where the angle is with respect to the x-axis on the coordinate system. Like, let's say you're dealing with an angle like 47 degrees. Well, the initial side would start from the origin and fall and lay on the x-axis. The terminal side, though, you'd measure out 47 degrees. I'm not actually measuring this out. I'm just kind of guesstimating, and have it out here. But this measure right here would be 47 degrees. Now, with the 47 degrees, with the terminal side being in quadrant 1, the reference angle is the same. Because the reference angle is the angle that the terminal side makes with the x-axis. Reference angle is a positive angle that the terminal side makes with the x-axis. So if you look at the terminal side here, the angle it makes with the x-axis is 47 degrees. But you can use that reference angle to find your sine, cosine, tangent, and so forth. And then once you get your values for that, to get the final proper answer, you assign positive or negative signs depending on what quadrant you're in. Okay? Remember, if you are in quadrant 1, all of your trig ratios are positive. If you're in quadrant 2, your sine is positive. If you're in quadrant 3, your tangent is positive. And if you're in quadrant 4, your cosine is positive. When I say positive, like if all are positive, that's sine, cosine, tangent, also their reciprocals are positive. Quadrant 2, when I say sine's positive, that same thing goes for its reciprocal, the cosecant. It's going to be positive. When I say tangent in quadrant 3 is positive, its cotangent is also going to be positive, and everything else will be negative in that quadrant. Quadrant 4, if the cosine's positive, then secant is also positive. Everything else is negative. And a way you can remember that is a smart trig class. A smart trig class. And that'll help you to remember what's positive in each quadrant. So you use the reference angle to find the actual number values, and then use this little trick to help you remember what SIGNs to apply. All right, let's say you have another angle. Let's say you have something like 140 degrees. Okay, if you were to draw that angle on the XY coordinate system, the initial side is supposed to start from the origin and lay on the x-axis, and then the terminal side is going to start from the origin, and it's going to be out here in quadrant 2. Okay? So when we construct this 140 degree angle, this part right here measures 140 degrees. So since we are in quadrant 2 for the terminal side, the sine and the cosecant of 140 degrees are both positive. Cosine, secant, tangent, cotangent are all negative. But if we want to work on trying to find the numerical values, what we can do is use the reference angle. The reference angle is the angle that the terminal side makes with the x-axis in that quadrant. Like earlier, over here, terminal side made 47 degree angle with that x-axis. But on this one, the way we figure this out for the reference angle is we see that going all the way over to the negative x-axis would be 180 degrees. But we've already gone 140 degrees, so we need to see what that difference is. It turns out a difference of 40 degrees. So the reference angle is 40 degrees. Because this angle 140 plus this 40 make the 180 straight across. But that's how you can find the reference angle in quadrant 2. Do a little 180 minus whatever this angle measure here is coming from positive x-axis. Alright, let's say we're dealing with an angle that's something like 230 degrees. Okay, initial side still starts from the origin and lays on the positive x-axis. Then the terminal side is going to start from the origin, and it's going to exist over here in the quadrant 3. So this angle here is 230 degrees. But we're interested in finding out what the reference angle is. What angle does this terminal side make with the x-axis in that quadrant? In this case, quadrant 3. So we want to figure out what the reference angle comes out to. Well, you've already gone 180 here, and then you're trying to figure out what this extra is to the terminal side. So you take the 230 degrees, subtract this 180, and that'll help you see what's left over. You get 50 degrees left over. So this reference angle is 50 degrees. So here we subtracted 180 minus the angle when we were in quadrant 2. Quadrant 3 we did the angle minus 180. So reversed order there. Okay, and then one more example for reference angle. Let's say we've got something that's landing in quadrant 4. Let's say we have something like 285 degrees. Okay. So for this angle, initial side does start from the origin and lay on the positive x-axis. Let's see here. And then the terminal side is going to start from the origin, and it's actually going to lay here in quadrant 4. Okay, so for this one, if you go all the way around like this, you've got 285 degrees. But for the reference angle, we want to take this terminal side and see how far apart is it from the x-axis on in that quadrant. So we want to find this value. Well, if you go all the way around, you've gone 360. But we haven't quite gone all the way around. But we can use 360 to help us figure out that difference. You know, if all the way around is 360, then let's say subtract 360 and the 285 to see what this leftover bit is here. And I'm getting 75 degrees. So that leftover bit there is 75 degrees. The 285 plus this 75 makes 360. So if you go ahead and, if you were looking at sine, cosine, tangent using 75 degrees, just make sure you watch your signs, SIGNs, and that'll give you the answers for sine, cosine, tangent of 285. So that's the deal with reference angles. Okay? So let's see how this applies when maybe we're doing finding some trig values or something. Let's say we've got a certain angle and they say, well, let's find the trig values for that angle. Alright, let's say they tell us that we have an angle of 225 degrees. Okay, so we'll go ahead and we're going to start from the origin, draw initial side here. Well, let's say we have, let's say we have a, well, you know what, I'm going to instead, I'm going to do this, I'm going to use that, and I'm going to, because we're going to draw like a reference triangle to help us with this. So there's initial side. And then 225 degrees. We've got from the positive x-axis up to here is 90, here's 180, here's 270. So 225 is going to take us over here. Okay, so if we measure all that out, this whole angle here is 225 degrees. Let's say that we draw ourselves a right triangle, a reference triangle here in quadrant 3, where the terminal side of this angle was. Let's go ahead and draw a perpendicular from the end of this segment to the x-axis. In essence, making a right angle right here. Let's say we want to figure out what the trig ratios are for the 225 degree angle. Well, we can use this reference triangle to help us. If we think about the fact that, you know, already from here to here is 180, we can subtract 225 and 180 and see what the reference angle would be. In this case, it would end up being 45 degrees. So this angle right here is 45 degrees. And we know that this is 45 and this is also 45. And that's our 45, 45, 90 special right triangle that we've worked with before. Well, the sine of 45, the cosine of 45, those are values we know. We know that the sine of 45, we already know that it's square root of 2 over 2. We already know that the cosine of 45 is also square root of 2 over 2. We know that the tangent of 45 is 1. We know that the cotangent of 45 is 1. We know that the secant of 45 is square root of 2. We know that the cosecant of 45 is also square root of 2. We know these values because that's some of our special angles we've talked about. Well, if we want to do the same thing for 225, sine of 225, you're going to be using square root of 2 over 2 also. But then you got to think about your little saying. A smart trig class. According to our saying, in quadrant 3 here, T for trig is telling us that tangent and cotangent are the only positives. Everything else is negative. So we can go ahead and say, well, this has to be negative then, according to what quadrant this reference angle is in, this reference triangle. When we go to do cosine of 225 degrees, it's going to be negative square root of 2 over 2. When we go to do tangent of 225 degrees, since tangent gets to be positive, it's just going to be 1. When we go to do cotangent 225, that's also going to be 1. When we go to do secant of 225, that's also going to be negative, so it's going to be negative square root of 2. And when we do cosecant of 225, that's going to be negative square root of 2. So the numbers, the ratios are the same, but the signs you have to watch. You have to watch what quadrant you're in. But knowing your special triangles, special angles, you can figure values out for not just 45, 30, and 60, but also for the angles that would have those reference angles in the other quadrants. Okay, let's do another one, but let's say this time let's say this time it's a negative angle. Let's do one with a negative angle. Um, let's say you got to figure out the exact value of the sine of negative 150 degrees. So you got to do that. Well, initial side's going to be on the positive x-axis. But the terminal side, let's see, we're going negative, so that means we have to go in a clockwise direction. Positive angles go counterclockwise, negative angles go clockwise. So clockwise, we're going 90, 180 would be too far, so we're in quadrant 3, about right there. So going this direction, we're at negative 150 degrees. So then you got to think, well, how much will make up right here to give us a reference angle? Because the reference angle takes the terminal side and looks at, well, how far is it from the x-axis in that quadrant? Well, if you went all the way, you'd be at 180. So how much would it take to go to negative 180? It would take another 30 degrees to get there. So what we're really looking at is finding the sine of 30 degrees and then thinking about, well, should it be positive or negative? But we now know what the sine of 30 degrees is supposed to be. It's supposed to be 1/2. But let's see, we're in quadrant 3, A, smart, trig. In quadrant 3, T for tangent is positive, but sine is going to be negative. So the sine of negative 150 degrees is going to be negative 1/2. So that's how you got to think about these things. Okay? All right, let's do a little bit of playing with the calculator. Let's explore, like, how do we work on these trig functions and things with the calculator. We've done some already, but let's do some more. And then I also want to talk about, like, inverses. Like, how do you do inverses in the calculator? And what does that mean? What does inverse mean? Let me see here. Alright, so when I do pull up my calculator, it's right there. Let's write down a couple of different things we want to look up. Let's use the calculator and find the tangent of 68 degrees and 43 minutes. Let's also look up the secant of negative 287 degrees. Let's use a calculator just to see some more about how to, type things in and so forth. All right. First of all, tangent of 68 degrees, 43 minutes. Well, that's the same thing as finding the tangent of 68 and 43/60 degrees. Because remember, there's 60 minutes in a degree and there's 60 seconds in a minute. Remember that from way back, couple podcasts ago. But let's put it in the calculator like this. It'll be easier to deal with. Or, I mean, you could also put it in like this. That's right. You can put it in the calculator like that. Either way. So whatever floats your boat. And then secant, don't forget that that's the same thing as 1 over cosine. So you don't want to be trying to use any fancy keys. Just say 1 divided by cosine. Alright, so let's do the first one. First of all, let's double check our mode, make sure we're in degree mode. Then, let's see, tangent. Yeah, why not? Let me go ahead and put in 68. Remember, the angle menu has degrees right there for number 1. And then 43 minutes. The angle menu also has, for number 2 there, the minutes. Then you can hit enter, and it gives you that tangent. Or if you put in tangent of 68 plus the 43 divided by 60, we'll just go ahead and take that as your degrees, and you should get the same thing. Alright, and then secant of negative 287, you can do 1 divided by cosine of negative 287, and then that should give you your value. And there you go. Now some of you, I keep saying don't use sine -1, cosine -1, tangent -1 here when you're doing your secant, cosecant, cotangent. And that's because those are inverse functions. You might be saying, well, you keep saying that, but what is that for? What is that used for? Well, let's say that you know that the cosine of some angle is 0.921185. I'm not making this up. I'm getting it from somewhere. But let's say you know that that's your cosine, but you're interested in knowing, well, what the heck's the angle? What if you know the cosine and need to go backwards and find the angle? Well, that's where you're dealing with the inverse. If you're trying to solve for theta, the angle, you can do the inverse cosine of the 0.92118541. And that's exactly what that key is used for on the calculator. You do secant cosine 0.92118541, and then hit enter, and then it tells you the answer. So apparently theta is 22.8999, lots of nines, degrees, like that. So that you can work backwards and figure out what your theta is. So that's what that's used for. You could also use it if you're doing like let's say you know cotangent of theta is this 1.4466474. Well, you know cotangent is of theta. Cotangent is the same thing as 1 over tangent. So you could also say that tangent is 1 over cotangent. So this is telling us that tangent of theta here is 1 over 1.44666474. So to find theta, we can do the inverse tangent of 1 over 1.44666474. So let's pull up the calculator. See, Smart View. Let's do inverse tangent of 1 divided by 1.44666474. Enter. And then there's your answer. So you're getting that theta is around 34.654300 roughly degrees, depending on how they ask you to round, but that's what inverse means. And you don't have to just use it with your calculator. Like if you know that your sine of theta equals negative square root of 3 over 2, then you're trying to figure out what theta is. Well, if you think about square root of 3 over 2, you know that the sine of 60 degrees is positive square root of 3 over 2. But in this case, if sine of theta is negative square root of 3 over 2, then think about your quadrants here. Smart trig class. Quadrants 3 and 4, your sine's going to be negative. So if you've got 60-degree reference angle here in quadrant 3, then theta must be 240 degrees because it's 180 plus that 60-degree reference angle. If you've got a 60-degree reference angle here in quadrant 4, then theta must be 300 degrees. Or at least if it's between 0 and 360, that would be your values. It could be other things too, like you could add or subtract 360 and get other thetas, but as far as like if theta is somewhere in the interval from 0 to 360, greater than or equal to 0, less than 360, then it has to be either in quadrant 3 or 4. It could be 240 or it can be 360 minus this 60 would be 300 degrees. Alright, now let's take some of this and actually apply it. Let's do a couple of application problems, and then that'll wrap this up, this little piece up. If you have something that's traveling up or down a hill, there's something called, there's a force, F in pounds. That's also referred to as the grade resistance. And there's an equation that models that. The force equals W, where W is the weight of the object, the automobile in this case, times sine of theta. Where theta is the grade. If your car is going uphill, then you've got theta right here, and it's going to be positive. If your car is going downhill, then you got your theta right here. It's going to be negative. So you can use this formula to help you figure out force in pounds, or if you know force in pounds, you can find the weight. So let's say you have a 5,500 pound car, and it's traveling uphill with a grade of theta being 3.9 degrees. And you want to figure out the force to the nearest 10 pounds. Okay, so you have your formula. Force equals the weight, the 5,500, times the sine of 3.9 degrees. Okay, so pull up my calculator. You do 5,500 times the sine of 3.9, and I get that. And it said within the nearest 10 pounds, so you can go ahead and say, well, this is 370 pounds of force. A couple of variations on that. You could have 2,800 pound car traveling downhill. And in that case, the downhill grade, you got theta equals negative 4.8 degrees. So let's do force to the nearest 10 pounds again. So force equals 2,800 times sine of negative 4.8 degrees. So pull up the calculator. 2,800 times the sine of negative 4.8 degrees. And you round to the nearest 10, you get around negative 230 pounds of force. The negative is because it's going downhill. Alright. Then another scenario, what if you know the car is 2,400 pounds and grade resistance, and they tell you the grade resistance is 288 pounds. And they want you to find the angle of the grade. But they also go ahead and tell you are going uphill, so you know it's going to be positive. In that case, you know that 288 equals 2400 times the sine of whatever the theta is, the angle. So sine of theta is going to equal 288 over 2400. And then here's where you can use that inverse key. Theta is the same thing as the inverse sine of 288 over 2400. Use the inverse key to help you find the angle when you know the sine. Oops. So let's do that. Second inverse, 288 divided by 2400. Enter. You need 6.89, so around 6.89 degrees for the angle. So that's the angle of the grade. Alright, so there's some applications also for using that inverse key. So remember, secant, cosecant, cotangent, you have to do 1 over cosine, 1 over sine, 1 over tangent. But the inverse keys, the sine to the -1, cosine to the -1, tangent to -1, we use those when we know what the sine equals but need to find the theta, the angle. Or if you know what the cosine or tangent equals but you need to find the theta, that's when you use the inverse keys. Okay, well that wraps up this little section. Thank you for joining us, and I look forward to seeing you again soon.